Electricity, lecture number 1. So, coming to the introductory part of the lecture, in this particular lecture, we will be dealing with electric current, electric potential, electrical components, circuit diagrams, Ohm's Law, and the factors affecting resistance. So let's start with the first topic, electric current. Now we usually get an idea that what is current. So whenever charges, which are electrons, flow, a current is automatically produced. Current is defined as the rate of charge flow. Current is denoted by the alphabet capital I, and the units of current is ampere. So by the definition of current, mathematically it is denoted as Q divided by T, where Q is the charge and T is the time. Note that the direction of current is opposite to the direction of flow of electrons, and the direction of flow of positrons is opposite to the direction of flow of electrons. Hence, the direction of flow of current is as same as the direction of flow of positrons. Now, let's solve two problems on this particular concept for a better understanding. So, the question is, a current of 10 amperes is drawn from the filament of an electric bulb for 5 minutes. Find the amount of electric charge that flows. So from the given question, I have the value of I to be 10 amperes, but the value of T is given in minutes, so I have to convert it into seconds. So 5 minutes is equivalent to 300 seconds. By using the given formula and on substituting the values, I get Q to be 10 into 300, which is 3000 coulombs. Note that the unit of charge Q is coulombs. Please remember this. Now let's solve the second problem. Here the question is, a charge of 100 coulomb is made to flow for 1.667 minutes. Find the amount of current that flows through the circuit. Okay, so from this particular question, the given value of Q is 100 coulomb and the given value of T is 1.667 minutes, which is equivalent to 100 seconds. So by using the formula of I equal to Q divided by T and now substituting the values, I have I equal to 100 divided by 100, which is equal to 1 ampere. One more important note here is the unit of time T should be always taken to be seconds. Okay, so whenever you have time given in minute or hour, please convert it into seconds. Now let's learn about electric potential. Please note that a current will flow only when there is a potential difference. An electric potential is defined as the amount of electric potential energy that a unitary positive charge experiences. An electric potential is usually applied or supplied with the help of a battery. Please have a look at the diagram. So on paper, electrical potential is represented by the capital letter V. So the units of electric potential are volts. So higher the value of V, higher is the potential difference for obvious reasons. Note that the V at the positive terminal is considered to be higher potential and the V at the negative terminal is considered to be a lower potential. These are just assumptions, please follow them. Current always flows from a higher potential to a lower potential. But inside the battery, the current flows from a lower potential to higher potential. For a further understanding, let us look at this diagram. Here, the battery does the same job of a water pump, and the water is similar to the current here. So the electric potential is also related to the work done and the charge by the formula given below, V equal to W divided by Q. The electric potential is measured by means of an instrument called as a voltmeter, and voltmeter is always connected in parallel across the points between the potential difference is to be measured. Now let's solve two more problems on this particular concept of electric potential. Okay, so the question here is a charge of 3 coulomb and a potential difference of 8 volt is given, find the work done. Okay, so from the given question, the given data is Q equal to 3 and the potential difference is 8 volts. So by using the formula of work done, which is W equal to Q into V, and on substituting the values of Q and V respectively, I get W to be 24. So the work done is 24 joules. Note the unit of watt or power is joules. Okay, W is the unit of power. The other question is a charge of 4 coulomb moves across 2 points and the work done is 24 joules. Find the potential difference. So in this particular question, I have charge to be 4 coulombs and the work done to be 24 joules. So by using the formula V equal to W divided by Q, and on substituting the values of W and Q respectively, I get V to be 6. So the potential difference required is 6 volts. I hope this is clear. Now let's move on to the electrical components which we will be using soon. So given below is a list of electrical components. Please have a look. This is just for your familiarity. So in general, different electric circuits use different electrical components, right? So obviously it is not necessary that we shall use only a particular component every time. They have to be used as per the need only. Fine, I hope things are clear. So coming to Ohm's law, very important part of this particular lesson. The law states that at constant resistance, the voltage is proportional to the current. So mathematically V is proportional to I at constant R. V equals to IR. Now, how is this relationship developed? So for this, we need to go through a particular experiment conducted by Sir Ohm. In this particular experiment, A graph of V versus I was plotted, and the graph was found to be linear. Hence, the relation of V proportional to I was generalized. The ratio of V and I was always a constant, which is nothing but the slope, and the slope, which was constant, was equal to R. So this is how the formula was developed. Now let's move on to the factors affecting resistance. Okay. So resistance is a very special property in the electricity subject. It is a characteristic of a component itself. The resistance of a wire depends on various factors. Some of those factors are temperature, the area of cross section of the wire, and the length of the wire. So let's learn in detail how each of these factors affect the resistance. So let's start with temperature. So the dependence of temperature. Resistance increases with temperature. Higher the temperature, higher will be the resistance. And this is the graph. Now let's look at the dependence on length. So resistance increases with the length of the wire. Higher the length, higher will be the resistance. So that's the reason why higher appliances like ACs and geysers have wires of shorter length. So lower the length, lower will be the heat emitted, obviously. Now let's study about the third factor, which is the area. So the dependence on area. It was found that resistance decreases with the increase in area. So higher the area, lower will be the resistance. And this is the reason why AC and geysers have thicker wires comparatively. So thicker the wire, lower will be the heat emitted. And similarly, you can have a look at the graph, which shows the inverse relation of the dependence of area on resistance. The continuation can be found in the next lecture. Thank you for watching.